Hi guys, you know the drill. Let's get into the future. Obviously, these are all estimates, but I'm 99.8% sure that by the year 2026 we'll be on Mars. And then Earth's magnetic field flips. You may be like, okay, so what? That means that up here is now the south, and down here is the north. Yeah, enjoy. And while it's flipping, there's a higher chance of you getting skin cancer. By the year 5000, the Jurassic sea level is rising. By the year 7000, a 30 meteor will strike Earth. Meow. Year 10,000, Antares goes supernova. It's a cool supernova. An entire 12,000 years later, in the year 22,000, Chernobyl finally becomes habitable again. 40,000 years into the future, Voyager 1 passes by the nearest star. In 100,000 years, there'll be a massive supervolcano eruption. Every now and then, thanks to micrometeorite impacts, the Apollo footprints on the moon just start to fade away. And in a million years, they'll be gone. In 1.5 million years, the famous star Betelgeuse will go supernova. And it will make the night sky bright even throughout the day for around a month. Phobos' orbit becomes so close to Mars that gravity takes over and Phobos gets ripped apart. Phobos is gone. Mars only has one moon left, although it has some nice rings. That's 30 million years into the future. Well, funny fact, even though Mars gets rings in 25 million years thanks to gravity, yes, the same thing that gave Mars a ring, gravity, is the same thing that will make Saturn ringless. Because the gravity pulls it in and the rings get pulled in inside the atmosphere. And then in 45 million years, Antarctica just melts. In 70 million years, a major asteroid collision is going to end up happening to Earth. Now, in 150 million years, there'll be a nice supercontinent. Oh crap! Something's going on with the sun. It's 400 million years. The sun has become a little bit brighter. Oh crap! Oh crap! It's been about 3 billion years, and the sun. The sun loses fuel at an alarming rate. So what does it do? Does it explode? Does it do something cool? Well, it just starts to expand. And at this point, it becomes so hot that all life on Earth just dies at that instant. 3 billion years, all life on Earth just dies. And the sun starts to grow big, big, and big. In 4.5 billion years, the Andromeda Galaxy collides with the Milky Way Galaxy, forming Milkdromeda. Oh crap, we forgot about the sun. No! All life, Mercury gets destroyed, Venus eventually gets destroyed, all the way until Earth. Earth evaporates inside the sun. The sun is so large, it just can't, its power, and then the sun is now gone. 8 billion years into the future, the sun has just been reduced to nothing but a tiny, 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 insignificant white dwarf. The sun is now dead. Its core is slowly cooling. This is the end of the sun, the end of our solar system. It is now as bright as the full moon if the Earth still existed. All stars in the universe just start to begin to just cease to exist and explode or die. Either way, it's the end of all. It's the end of all the lost stars in the universe. Red dwarfs begin to die. All that's left are neutron stars, main sequence stars, black holes, nebulas, and white dwarfs. All of these are just dead stars. Gravity ejects these dead stars' corpses. Gravity ejects these dead stars outside of their galaxies. By chance, brown dwarfs may collide, making accidental new stars. Eventually, neutron stars begin to collide in 30 quintillion years, making a massive kilonova. If it couldn't get worse, in a septillion years, white dwarfs like our sun begin to die and turn into the first ever black dwarfs. It takes so long to get to this point that scientists think there is no black dwarfs at all in the universe. Any remaining matter that does not get ejected from the galaxy gets eaten by a supermassive black hole at the center. Universe expansion goes so fast that it's going faster than the speed of light, meaning that if civilization were to somehow form in one solar system, they would think that their solar system is the only thing in the universe, since they literally can't see any stars. 10 to the 36th, which is 1 undecillion, atoms, literal atoms, start to decay, and then protons start to decay right after. A duodecillion years into the future, all that's left in the entire universe are black holes. But the thing about black holes is Hawking radiation. I hate to break it to you, but matter constantly keeps escaping a black hole. What do I mean? So, every now and then, antimatter and matter just spawns out of nowhere. And at the event horizon of a black hole, like this little edge, the edge of the black, well, about that part, antimatter either here or out here, and matter either here or out here are just made. So usually they're just antimatter and matter will just come and then destroy each other. But when it comes to here, one of them gets sucked into the black hole and the other one flies out of the black hole. This makes the black hole get smaller, and this, when it gets smaller, is Hawking radiation. Now, because of this, black holes just fade from existence, leaving the last light in the universe. In a trillion years, the universe becomes absolute zero. In a Google years, universe expansion stops. So, the bigger the black hole, the longer it will last. Now, Phoenix A, the largest black hole in the universe, slowly dissolves into nothingness. And just like that, Phoenix A ceases to exist. And this is a Google years in the future. And then, universe expansion just stops. Everything stops. Time becomes meaningless.